and this is more from our discovery activity. We may have talked about it a little bit before you left yesterday, but symmetry. What did you notice about symmetry? Okay, if it was cosine, it had symmetry for it over the horizontal axis. Okay, and if it was a function with sine, it had symmetry over the vertical axis. Did everyone else make that observation? Okay, for the graphs that we do today and tomorrow, that's going to be true. So, if we have a function, r equals something with sine, we are going to have symmetry with respect to the vertical axis. Okay, since we're doing polar coordinates, we don't call it the x and y axis. Okay, we'll just call it the vertical axis. And then if we have a function in terms of cosine, we know we're going to have symmetry with respect to the polar axis, or the horizontal axis. So let's talk about the beginning of your notes sheet. You had functions that looked like this. Okay? We made some observations. Okay? What happens when n is odd? That's how many petals you had, right? What happens when n is even? It's double. Okay. So tell me, what would we have if n is 1? One petal that is actually circular, right? Okay, so the first thing I want to talk about is circles. There are 3 different ways to make a circle. Who can give me one? So what would that look like in an equation? Okay, that's beautiful. How about in polar form? R equals 4, R equals 1, R equals any constant. And that is a circle centered around the, what do we call it? The pole. Where our radius is A. What's another way to make a circle? That's about it. Okay, a rose curve with just one petal. Alright, so let's talk about this case right here. You played around with functions like this yesterday. R equals A cosine theta. Where does this put your circle? Okay, first of all, it's going to be symmetric about the horizontal axis because we have a cosine. Okay, and then where's our circle actually going to be? Is it going to be centered at the pole? Okay, is it going to be to the right or left then? It's going to be to the right. And in this case, A stands for what? Okay, in relationship to the circle, what would A be? The diameter. It's going to go out A, alright, so that is our diameter. Okay, what happens if we make A negative? It's going to come over here on the left side. It would flip over the vertical axis. Okay. Good. You guys know everything I'm talking about already. The next one. Alright. R equals A sine of theta. Where does this put the circle? okay, on the vertical axis, above the pole, okay? Or once again, our diameter is A, and if it's negative, where would it put it? Below the pole. Okay, so circles, these should be the easiest for you to draw. Okay, so on your worksheet today, you're going to get something that looks like this. You will be given an equation, a nice polar plane, and this right here. Okay, you're going to have to fill this out for every single graph that we do. So first of all, look at the equation. What is the shape? Okay. And do we know our max R value? Should we make our picture first?
Yes.
Okay. Let's remind ourselves. First of all, it's -5 sine of theta. So it's vertical, and where is it going to be? Since it's -5, it has to be below. So we start, and our diameter is 5. Ooh, that was bad. Alright. So, please tell me, what's our max distance from the pole? 5. That's your max R value. Okay. Now let's talk about zeros. What do I mean by zeros? No. Still wrong. When is R 0? At the pole. So when we talk about zeros, we're talking about where it hits the pole. Okay? Yeah. So first of all, when we start drawing these graphs, where do we start? When theta is what? 0. Okay? So let's just say when theta is 0, what is R? 0. Okay? I'm not going to mess with pi over 4. Okay, let's do another nice value. What about when we plug in pi over 2? Where are we? Try to -5. Makes sense, right? At pi over 2 is here. We go backwards 5. That's how we're drawing our circle. Okay? And then what about when we plug in pi? 0. Okay? Do you remember when you plug these into your calculator, they'd actually like draw them out? Okay? When your calculator traces that function, it's going from when theta is 0 and increases. Okay? So when your calculator would draw this, it starts at the pole in this case, and then it stops at the pole. Okay? How many times did we go through the pole? We touched it twice, didn't we? We started at the pole, and we ended at the pole, didn't we? So we actually have 2 zeros. And where are they? Okay. Now, we plug numbers in. Okay? You don't have to do that every time. Do we know a way to solve for zeros? Zeros means R is what? Okay. So if R is 0, that means we're looking for when the sine of theta is 0. And when does that happen? 0 and 2 pi, and so on and so forth, right? But in this case, we only have 2 zeros. When you have a circle not centered at the pole, it's only going to go from 0 to pi. And that one petal only goes from 0 to pi. I'll tell you that right now. Any questions? Okay. With circles, I don't care if you solve for the zeros or if you plot the circle and think about it. Okay, but as we get into our rose curves and our what we call rhinotons tomorrow, we'll want to actually use some algebra. Okay. All right, circles. Can you handle them? Okay. Let's talk about rose curves. Now I know they are called rose curves and they look like daisies. That bothers me, but we'll get over it, right? Okay, so these are the 2 different kinds of equations we can have. Now, you have already told me that when n is odd, what does that tell us? Okay, n petals. When n is even, we have 2n petals. Okay. Now, we already know that in terms of cosine, we're symmetric about the horizontal axis. Sine, symmetric about the vertical axis. Yes? No. Did everyone hear that? He asked about the circle r equals 4. It's centered at the pole. There are no zeros because it does not go through the pole. Okay? Okay, so back here, we know the symmetry for each of these, right? Let's think about where they start drawing, okay? So everyone get out your calculator. Okay? Or did anyone make that observation yesterday, where they start drawing these growth curves? One of them starts at the pole, one of them does not. Okay, so one of them starts at the pole. David thinks one of them starts on the positive side of the horizontal axis. Sine starts where?
Cosine starts behind them.
Okay, the cosine begins on the horizontal axis. Why would that make sense? What is the cosine of 0?
Zero.
What's the cosine of 0? 1.
1.
Okay, so we always begin when theta is 0, correct? So if the cosine of theta is 1, we begin r away, correct? We begin at the length of our petal. Okay? Now, what's the sine of 0? 0, which means this one is going to begin at the pole, because when you plug in 0, you're going to get 0. Okay, which is why you see that first petal in the first quadrant. Right? Okay. What does A tell you? What do you mean how big it's going to be? Okay, A going to tell you your max R value, okay, which corresponds to what with our pedals? How long our pedals are. Okay, this is the length of our pedals. Okay. So if A is 4, each of our pedals has length of 4 from the pole. Alright, we ready to graph them? We're doing these without our calculators. Can you use your calculator to check? Sure. But you're going to graph on your quiz and test without a calculator. So here we go. First one. We know by looking at the equation, the shape is what? It's a rose curve. And specifically, how many petals? 4 petals. Okay. What's our max R value? Okay. We'll worry about the zeros here in a little bit. Okay, let's get our first petal drawn. Okay. I will tell you, anytime we have one with sign, the beginning of the curve is just a little trickier, because where do we begin? When theta is 0, what is R? 0. We need to figure out where the heck our first petal is supposed to land. Okay? So, when you have a rose petal with a sign function, we need to think about when is the sign, well, our petal has length 4, correct? Which means we need this to equal what? If R is going to be 4, sine of 2 theta would need to be 1. Okay, so our first petal is going to be when the sine of 2 theta is 1. When is the sine equal to 1? You guys are killing me. When is the sine equal to 1? Pi over 2. Which means our angle needs to be pi over 2, which means what is our angle? Okay, so when I plug in pi over 4, this gives me 1 times 4, and that is where our first petal will land. Okay. How many petals are there going to be? 4. And they span out over the entire graph, okay? And how many radians are in this graph? How many radians? 2 pi. So if I have 4 petals, okay, I have 2 pi radians split into 4 petals. How far apart are they going to be? They're going to be pi over 2 apart. Okay. So now this is how we draw it. Okay? It doesn't really matter how you trace it out. Okay? See? There's 1 petal. And it actually does not trace it like this. It traces it differently, but yeah. Okay. So there we have it. There's our beautiful rose. Okay? Now, let's talk about our zeros. We started at the pole. So that's 1, 0, right? How many times do we hit the pole? Okay, so we start at the pole, that's
1, 2, 3, 4, 5.
when we start at the pole, yes. Okay, when we start at the pole, this was 1 more than the number of petals, right? But count it out, okay? It doesn't hurt. So I need 5 zeros here. Okay? How do we find our zeros? Okay? We want R to be 0. Which means we need the sine of 2 theta to be 0. Okay? Which means we need our angle 2 theta to be, when is the sine 0? We need how many of them? We need 5. So first place. First place, 0. Next place. Next. Next. Next place. There's 1, 2, 3, 4, 5 of our zeros. Now we need to divide by 2. Yep. Because 2 theta equals this, I want theta. So it's not going to be 2 every time. It'll depend on the equation. But, okay. Now, when it says significant points, I need at least the first 2. Okay. And then from there, you can figure out where to space your petals. I'm not going to make you fill this all out with all the points that we have. Okay? Get your petals started with a couple points, and then space them out. Questions? Roll it back down. Okay? We're going to do 2 more of these, so by the end of it, we're good. Okay? Nice thing is, from yesterday, you know what these are going to look like. The part that you're worried about is where exactly everything's going. Next one. Shape. Rose with 3 petals. Max R value is 5. That's how long our petals are going to be. Now this is nice. When theta is 0, the cosine is what?
Cosine is I have a good.
Okay, I'm asking you about these. What's this point? What's this point? At 0 degrees, what's the cosine? 1. What's 1 times 5? Okay, that's where our petal starts. Right?
Yes.
How far apart will our petals be? How many of them are there? There's 3, and so we have 2 pi radians split up into 3 petals. Okay? You can think of degrees if you'd like. Okay? What's this in degrees? 120, so here's 30, 60, 90, right? Okay, and then 3, 6, 9, 12. Okay. So now let's trace this out. Count how many times I hit the pole.
2, 3.
So how many zeros are we have? 3. Yep. Now how do we find them? We set R equals 0. Okay, divide by 5. Okay, we need 3 zeros. So we need the first 3 times cosine is 0. So our angle 3 theta equals, when is the cosine 0 first? Pi over 2. Then where? 3 pi over 2. And then at 5 pi over 2. So now we are going to divide by 3. Pi over 2 divided by 3. 3 pi over 2 divided by 3. And 5 pi over 2 divided by 3. Okay. So our next point right here would be the pi over 6, 0. Okay? Now, what do you notice about our zeros? They're in between what values? 0 and pi. Okay? Anytime this is odd, when you draw out your curve, you only need to go from 0 to pi. But when you have even number of petals, you'll have to go from 0 to 2 pi. Okay, that's really not going to affect how you do anything because you're going to find the zeros, okay? And you'll know how many to find, okay? But I want you to kind of make that observation. Okay. Questions about this example? Okay? All right. No, we're in the smart. Okay, so you guys are going to lead me through this example. It's a rose with 4 petals. Okay. Okay, so, okay. So where do we start? Where do I go now? Okay, well first we plug in 0 for theta, okay?
Yes.
Okay, so we have 2 pi radians to split up into 4 petals. Ooh, this is... Okay? Now what? Four zeros. Set R equal to 0.
Divide by 3.
So 2 theta equals... I don't know, you guys are
It's
yelling
pi
it
over
off.
2. Pi over 2.
Pi over 2.
Pi over 2. And then another pi plus that is going to be
5 pi over 2.
7 pi.
So when we divide by 2, our zeros are
Pi over 4. Pi over 4.
okay. Now we do have time to do another one with sine. Do you want to figure out where that first pedal is going to be, or do you feel comfortable with that? Right here? This is just our first zero. Yeah. Yep.
How do you figure out how many zeros there are just by looking at your baby?
If it's cosine, what do you notice between this and this?
It's twice.
Pedals, zeros.
Sine.
Pedals, zeros. This one is sine. Here's your pedals. Here's your zeros. Okay? So here we go. Shape. Rows with 3 pedals. Max R. Okay. We need to figure out where, if we have R theta. When theta is 0, what's R? 0. That's why these are tricky. We need to figure out when this is going to be 1. Carl is here today. Okay. So, when is the sine of 3 theta equal to 1? When 3 theta is pi over 2, so our angle is, okay, so our first pedal is going to be at pi over 6. Okay, and there's 3 pedals split up over 2 pi radians, so they're going to be how far apart? Okay. 3, 6, 9. 3, 6, 9. Okay, so we begin at the pole. How many zeros? Okay. Okay, pedals plus 1 if it's a sine. Okay, and then you guys can find the zeros, right?
Yes.
Alright, feel good about this, guys.
Good.